Well, good morning and good afternoon for some. My name is Brian Moore, and I'm the SVP of Sales and Marketing here at Condusiv Technologies, talking to you about how you can achieve a 2x faster SQL experience guaranteed. This webinar is really broken out into two parts. The first part is the thought leadership portion of this webinar, where we just dig in under the hood, under the technology stack, to explain what are some of the I/O inefficiencies that are occurring, some I/O degradation issues that are occurring in environment if you're running SQL Server, particularly if you virtualize that environment. What's happening under the hood that's stealing the underlying IOPS and throughput, that's causing your underlying storage subsystem to work much harder than it should, and ultimately why you're getting less performance than you actually should on your SQL workloads. There are some inherent I/O penalties that are occurring, a couple of them that we will bring to light. And then once we give that overview, we will be then giving just a very quick, no more than a 10-minute overview of what our software does. It's just set and forget software utility, runs in the background on a Windows server, and it's tackling those I/O inefficiencies that we're talking about, solving them, so we can guarantee, at least for our customers, a 2x faster SQL experience. Obviously, the compelling event about that is what other way can you get more performance on your SQL servers other than just having to buy expensive hardware and throwing hardware at the problem. We're a unique solution that can actually solve that problem with a 100% software approach, and giving an NFR, a more than $500 MSRP value to you after the webinar is over, because ultimately the proof is in the pudding. On the line with me is my cohort. His name is Gary Kwan. He's the SVP of Technology Strategy. We call him GQ around the office, mainly for his lifestyle and his pinstripe suit. So GQ, thanks for joining me today.
Brian, always glad to join you on there, and don't let them fool you. I'm the tech guy here, so I'm in Levi's and a t-shirt. And Brian there, although his title says SVP Sales Marketing, he's a techie too. Now, one thing I do want to mention, Brian, is that we do like to make this session interactive. So there's a Q&A box over there. So as we go through the sessions and you have questions, write them up, and we'll either get to them during the session or at the very end. So thanks, Brian.
Yeah, and when you do type in the Q&A box, if you can, there's an option to send your question or comment to all panelists. Please do that so both GQ and I can see what your comment or question is, and because we do like this to be interactive. We will move to a full Q&A at the bottom of the hour, but as some of those questions start rolling in, we'll address as we go along. Now, here, you may join today, and some of you may not have heard of Condusiv Technologies, and you may wonder, well, why in the world do we have any thought leadership to even be speaking on the topic that we're speaking about today? I don't like companies that spend a lot of time on their corporate slide, because I want to get right into the content. But just to give you a little idea of at least what our street cred is, we're actually a 35-year-old software company, 12th oldest software company in the world. We originally started as a company known as Diskkeeper. Some of you may have heard of that company. In fact, you may have used that software in the past for hard disk drives. But about 5 years ago, the company brought some very revolutionary intellectual property to the marketplace that had absolutely nothing to do with fragmentation, but it was all about how we can reduce the noisy I/O, all the noisy and unnecessary I/O. And as it turns out, on any given SQL Server system, there's anywhere between 30 to 40% of I/O traffic that's just pure noise. It's just stealing IOPS, stealing throughput. In fact, those customers of ours who add just a little more memory server side, take more advantage of our software, they're offloading 50% or more I/O from storage and getting well above 2x faster gains. Now, for this work, Gartner named us Cool Vendor of the Year. When we launched to the marketplace. We've now had this product in the market for about 5 years. We've had very nice growth. It's now used across more than 2,500 mid-market, large enterprise customers. Iterations or pieces of this technology are OEM by Samsung, HP, Dell, Lenovo, SanDisk, Western Digital. So if you haven't heard of us, you've heard of them. Close relationships with Microsoft and VMware, and this is a big one, GQ. You led this initiative, and it was a couple months ago. Microsoft named us as the first ever software vendor certified for their SQL I/O reliability program. That was a big deal.
And you're right, Brian. I consider this a nice elite certification. Microsoft has certain levels to make sure that, other applications like ourselves are fully compatible with their software, in this case, SQL Server. And as you said, we're the only software vendor in there, but we're in good company with people like EMC, Dell, HP. But besides all the testing, we also had to go through a panelist of SQL experts to get past this. So this is a nice certification, Brian.
Yep. So before we jump right into the thought leadership portion, explain what's happening, what's creating all this noise, the unnecessary I/O traffic. What is this I/O degradation issue that steals performance? Let me just first give you a couple of opening slides very, very quickly, just some market research that we've done that you might find interesting. Earlier in the year, we conducted what we believe is the largest independent study done on I/O performance. Over 1,000 IT professionals responded. We asked this one very pointed question. We said, regarding all those really hard-hitting apps running on SQL, how many of you have performance problems so bad that you're actually getting staff or customer complaints due to sluggish performance? Slow queries, slow reports, batch jobs too long. Well, if you look at that graph, you'll see that 28% of all organizations, raise their hand and say, yep, that's us. We have slow SQL performance, bad enough where we get complaints. Now, the funny thing is, so we've done this given this exact same question in the year prior and the year prior, and this number continues to slowly worsen. Now, last year was 27%, not heavily or demonstrably different than this year, but you can see that there's this kind of slow creep of this I/O performance gap between what's being demanded from the applications and what the underlying storage and server-to-storage is able to actually deliver on I/O performance. So the likelihood you're on this webinar is because you're in that 28%, and just to let you know, you're in good company. So no surprises if more than 1 in 4 organizations are having an issue. So, and we did ask this question. We said, of all your I/O intensive apps that you support, which one is the most challenging, where you are struggling and running into the most performance issues? Well, we did a word cloud of across hundreds of responses, and you can see that the application name is representative of the number of times it was mentioned in the survey. So what jumps right out to you is SQL. And what we have found out is that over the years, even though our software is application agnostic, it can be used on any I/O intensive system. Our sweet spot really is with SQL, and that is also because of some inherent inefficiencies with SQL. And for that reason, 7 out of 10 new customers that come in to use our software, they're buying it to boost SQL. All right, well, let me just jump onto this slide. I think the setup here was long enough. Before I give you a picture of actually what's occurring or creating these I/O degradation issues I'm talking about, I think it starts, or it helps to start with the view of actually what a healthy I/O profile looks like. What is an optimal I/O profile where you're getting optimal performance? As you can see here on this screen, this is a very rudimentary abstraction, obviously, of your I/O profile, but I think that the takeaways are pretty obvious and immediate. You can see here that you're getting nice, large, clean, contiguous writes and reads. You can see you're getting a healthy payload of data with every I/O operation. You can notice how nice the sequential nature of your traffic looks. This is an optimal environment to get optimal I/O performance from your underlying flash hybrid or disk storage. But the moment that you take a SQL Server and you virtualize it, and obviously you're running that SQL Server on the Windows OS, the previous slide is not what you get. Instead, what you get is something that looks much closer to this. And by taking a quick look from what you saw before to what you're seeing here, I think that you've all seen the immediate takeaway. Suddenly now in this environment, there's I/O characteristics that are much smaller, more fractured, more random than they need to be. It's what we call a death by 1,000 cuts scenario, where your underlying architecture is processing workloads, but ultimately having to work much harder than it really needs to. And this is akin to pouring molasses all over your flash storage or your hybrid storage or your disk storage, because now you're penalizing storage performance with what we call the perfect trifecta for bad storage performance: small, fractured, random I/O characteristics. Now, if we dig in under the hood and say what's actually going on, what's causing this, you can see that there's actually two different what we call I/O penalties that are occurring, that are penalizing your performance and causing those I/O characteristics to break down or degrade. The first one is the I/O blender effect. The I/O blender effect, it's likely that you've heard of that term. It's a term that we helped Gartner coin a little more than 5 years ago when virtualization was coming across the landscape. And the I/O blender effect is what happens when the moment that you virtualize more than one server, and you put more than one server on the host hypervisor. In a physical server, in a physical environment, you get a one-to-one relationship between that server and underlying storage, nice sequential traffic. But the moment that you add one server to that host hypervisor, there is no fix for what happens. As great as virtualization is for server efficiency, the one downside is how it adds complexity to the data path. And what happens is that host hypervisor now mixes and randomizes those otherwise sequential I/O streams and now delivers a storage a more randomized pattern. And the moment that you add a third VM and a fourth VM, guess what you're doing? All you're doing is you're just amplifying the effects of that randomization even further. Now, most organizations don't see the full performance penalty that comes with virtualization and that added complexity to the data path because they have a tendency to virtualize slowly over time. But some of our biggest and best customers are those customers that went from 100% physical to 100% virtual overnight by flipping the switch. And GQ, a good example of this was a customer of ours that you worked with, Christus Health, one of the top 10 largest healthcare providers in the U.S., number 2 in Texas, and they virtualized one particular environment, over 2,000 servers that were physical. They moved them all to virtual overnight. And GQ, I know you were there. What happened?
Well, you know what? They did their testing on individual systems, and they expected when they went to physical to virtual, they get the same performance. But when they virtualized all those systems, they did not. They got a performance degradation. And during their analysis, what they found, it wasn't CPU, it wasn't memory, it was I/O bottlenecks, Brian. And that's what caused their issue there. Now, their first reaction was, we're going to upgrade our storage here. We're going to go to all flash array here to try to solve this issue. But before they did that, they got our software, and we solved their issue of their I/O bottlenecks, Brian. So rather than spending that $2 million for all new flash array, we saved that for them.
Yeah. In fact, you can go to our website and read the case study, how we doubled performance for them, and were able to keep them in their infrastructure that they had. Now, as difficult as that penalty is, there's actually an even worse penalty happening up further up the stack, at the very top of the stack, and that's coming from the Windows operating system itself. Now, you may be joined in, and you may have heard some allusions to this, but we're the ones who can actually explain it because we do have the only proprietary software to solve this problem. And that's the fact that the Windows operating system simply doesn't play well in a virtual environment. It doesn't play well in any environment where it's abstracted from the physical layer. There's some severe inefficiencies in the handoff of data between the Windows OS and the underlying storage. There are no APIs that connect the two other than using the rudimentary framework that Windows has always used by addressing a logical disk to write data. And GQ, this creates a real serious problem because the Windows operating system, for any given file that should be written and read with one I/O or 2 or 3 I/O, minimal I/O operations, Windows ultimately takes any given file and breaks it down to be much smaller than it actually needs to be. And ultimately what happens is you end up in a situation where you're processing 4 I/O or multiple I/O for a single file that really should all be written and read with one I/O. So maybe GQ, you could just tell us a little bit of what's actually happening here. Why is Windows so inefficient in the handoff of data?
Well, the Windows file system takes a one-size-fits-all approach, Brian. When a file gets created or extended, the Windows file system doesn't know how big that's going to be. So what it does, and this is all on the logical side on the Windows system, it looks for just basically the next fixed allocation. And if that file or extension is bigger than that and it fills that up, it has to go find another allocation, and so forth and so forth. Well, each of those allocation is an extra I/O. So now you're getting all these small random I/Os rather than nice sequential I/O. And later on, we'll go into how we solve this. But as you see, now you're getting all these small random I/Os coming from the system itself. And if you ever look at benchmarks of storage, they give you two, Brian. They give you random I/O and sequential I/O. And you always notice that nice sequential I/O always outperform the random I/O. So if we can, enforce the system to do these nice sequential I/Os, you're going to get the best performance out of your storage.
Yeah. Now, GQ, a good example here, this is a case study that was recently published with the University of Illinois. The University of Illinois, their hardest-hitting databases with their applications, they actually had some Oracle databases that were hard-hitting, and then also some SQL databases. They were already running those databases on the latest Dell servers. They had installed the latest, Dell compelling all-flash arrays in their environment and for their hardest-hitting databases. And everything was running fine on day one, but after about a year, some of that performance began to degrade, and they thought that they'd have to simply go buy more all-flash arrays for more IOPS to meet those SLAs. But before they did it, they heard about what our software does. The valuation is free. They thought they had nothing to lose. They installed the software, and we more than doubled performance in that environment on top of their all-flash arrays. They just couldn't believe to uncover, and this is true of all of our customers. It's just so shocking to them to find out how inefficient these systems really are, even if they have the latest new big iron sitting there in their environment to process I/O as quickly as they can. So if you take a look here at the next slide, I mentioned that I would give just a very quick overview of both GQ and I here, what our software does, and then we'll talk to you about the handoff of the NFR that we're giving you that you can download and install seamlessly, literally 5 minutes in your environment, and start seeing the benefits. But V-locity is I/O reduction software. It's set and forget software that installs right into the Windows operating system. It's a very thin filter driver, nominal overhead. We call it near zero overhead. We challenge you to even see the CPU footprint. It's enormously lightweight, and the CPU resources it does use, it runs at lowest priority, so it's never interfering with your server performance. And what the software is doing is it's actually offloading I/O from the underlying storage, and then at the same time, whatever I/O does remain, as GQ mentioned, we're streamlining that I/O traffic. So it's a friendly I/O profile for your storage to process much quicker. And we do a couple different things. We have two patented engines within the software that you should just be aware of what it's actually doing. We have a patented write optimization engine. We have a patented read optimization engine. So we're doing one thing to optimize your writes. We're doing another thing to optimize your reads. GQ, let's start first on what we're doing to optimize reads. We already talked about how Windows has this issue where it's only looking for the next available allocation at the logical disk layer, whether it's the right size or not. Now, we'll give Windows some credit in the sense that if it is a freshly formatted NTFS volume, you will get ideal I/O performance on day one because it's freshly formatted volume. The next available allocation is always the right size. And you get nice sequential traffic. You get nice, large, clean, contiguous writes and reads. But GQ, as time goes on, as files are written and erased, rewritten and extended, that's where this issue really begins to degrade and break down, where the next available space, GQ, if you're trying to write a 1 meg file, if the next available space is 4K, it will fill that 4K, split, find the next available allocation, fill, split, rinse and repeat until the file is fully written. And GQ, we have patented technology that can actually solve that problem and ensure that we're delivering every file with an optimal density. So maybe you can just share with us a little bit, what kind of intelligence are we adding here to enforce this type of optimization on the Windows OS?
And Brian, as I said before, the file system doesn't know how big that file creation or extension is going to be. So as you said, it just looks for the next allocation. Well, we're doing something very simple. In the background, we're monitoring your system, and we're saying, hey, this file type or this application, when the file gets created or extended, we know from our behavior analytics, our monitoring, that it's going to be so big. We just feed that intelligence back to the file system. So the file system now says, here comes this file creation. I'm going to look for the best allocation to put this so I get a nice sequential write. So now it's very simple. We're just providing intelligence to the file system so it can do a better job. And I like to use this analogy. If you want to carry a gallon of water from one place to another, do you do it 100 small Dixie cups, or do you just do it with one big gallon, do it all in one time? And that's what we're helping the file system enforce. Nice sequential writes, which is more efficient and more optimal. Brian.
Thank you, GQ. So the net takeaway is that intelligence helps the Windows OS find the best allocation at the logical layer instead of the next available, which is rarely, if ever, the right size. Now, GQ, that's as powerful as that engine is, and as much as that engine alone helps customers, it's not the only thing that we're doing. We have a second engine, a read optimization engine, and this engine is very, very different from the first engine. This is actually a DRAM read caching engine where we're establishing a tier 0 caching strategy in your environment by simply leveraging the idle available DRAM sitting there on any given VM or physical server. And we're just utilizing any of that memory that's just sitting there idle and free, that's going unused and otherwise wasted, and we're using that portion to serve hot reads. So the real genius in this engine is that it's completely automatic. You don't have to carve out or allocate any memory for cache. The software is just aware moment by moment of how much memory is unused in any given moment, is only using that portion to serve hot reads. So that way, you're never having an issue of resource contention. You never have to worry about memory starvation, because the intelligence of this engine is completely dynamic. Now, obviously, if you're running a heavy workload and you're memory constrained and you're under peak load at 3 p.m., well, then this caching engine isn't going to kick in if you're memory constrained and you're using all of your memory. But if you have slightly over provisioned on memory, or you're just not using all of it, this software will put that to work. Now, I know a lot of people, sometimes they hear this and they think, well, when it comes to caching, we need to be capacity intensive to really take a strong advantage of that cache. And GQ, that simply isn't true. We have found that if customers can maintain 4 gig of free available memory on some of their systems, that 4 gig oftentimes serves up to 50% of their read traffic from storage. So it's not always about being capacity intensive. Our behavioral analytics engine is so powerful, we can leverage just a little bit of DRAM, and keep in mind it is 15 times faster than SSD. So just a little bit of capacity can have a huge impact on offloading a lot of that noisy I/O, those hot reads that would otherwise have to go the full stack down the storage and back.
And you're right, Brian. There's 2 things that are very unique with our telemetry caching, and that's why we have 9 out of the top 10 PC OEMs, manufacturers license our technology. Of course, you haven't heard of us because they license under them, but the 2 things is, as you indicate, the dynamic memory usage. And, we'll only use what's available, not being used out there. And if any system or user process wants memory, we automatically give it up, so there's no memory contention. Now, the second part is, our intelligence of what to put and keep in cache for the best benefits. A lot of caching technology just uses something like, oh, hey, this data was read in, let me put it in cache and hope that it gets read in again. Well, we're not doing that. We're actually mining the system in the background, and we're seeing what data is going to get, first of all, what data is going to get cached the most. And then second, what data, if we cache it, will give the best performance gains, because there's some data that will give better performance gains than the other. It's actually the small IOs that are really, that gives the biggest dent in your performance. So we weigh that more to get the performance back. And so what we're doing here is we reside on the VMs, on the systems, and if we can cache that data, that means we can satisfy those reads right there and prevent that I/O from having to go to the network down to the storage get satisfied. So you can see the big performance gains that prevents, that gives you. And it just offloads all that I/O traffic and increases the bandwidth of the network storage for other things to be used for, Brian.
Yep. Now, if any of you are a Gartner client, you can check in with them. They do call us the world leader in caching, DRAM caching technology. We can't say that we know that we are for sure, but we believe we've sold more caching licenses than any other player in the marketplace over the years. So let me just outline just at least some real-world use cases. I know that we're getting short on time. I'm not reading all these. I'll just highlight a couple. You can go to our website. We have lots of case studies, all of them citing at least a doubling of performance of their SQL performance and other I/O-intensive systems. Good examples like ASL Marketing. They had a huge import batch job that they would do millions of records. It would take 27 hours to complete. They didn't have it in budget to rip and replace their hybrid, with all flash. So they tried our software, and we reduced that 27 hours down to 12 hours. It was a 15-hour reduction. And again, they couldn't believe that these systems are really that inefficient unless you're doing something to address the root cause problem in the first place. Just another example, Stockport College, they actually crashed on enrollment day due to I/O demand. It was taking them, on average, 15 minutes to process one student record. Again, another situation. They just didn't have it in budget to rip and replace their hybrid with all flash. And they installed our software, and we dropped that 15-minute average down to 5 minutes. And got them back into meeting their SLAs and not crashing due to I/O demand. So much success there, they knew they had a long-running payroll batch job on SQL. They put the software there, and it was taking an hour and a half. Even I couldn't believe this when we cut it down to 10 minutes. It just underscores how inefficient these hardware systems are in processing I/O unless you're actually doing something to address your I/O profile of what's being handed. Now, on this slide, these are just some examples that haven't made it in the case study form yet. One example here, Alberta University. You can read the others on your own on here, but Alberta University, they had 3,000 students. They were all accessing an LMS package, and students were taking tests, and they were timing out due to I/O demand. So without the budget to rip and replace their back-end architecture, they just simply tried the software. We doubled performance. More importantly, all the timeouts stopped, and we were able to enable them to get more life out of their hardware infrastructure by eliminating all that noisy, unnecessary I/O and eliminating those I/O bottlenecks. So let's just take a look at one quick screenshot of the UI. The software itself is, of course, just a software utility running in the background, doing optimizations in real time. The only time you ever pull up the UI is just really to see the benefits dashboard, to see what is the software doing for you. On the screen in front of you is just what the median results look like on a typical system that has at least 4 gig that we can leverage for cache. You can see this one was actually done in a snapshot, was taken over a 3-week period. You can see the total IOs eliminated from storage. In the top middle, it shows you the percentage, the number and percentage of your read traffic we're offloading from storage. Clearly, most all of that coming out of cache. You can see what we're doing for them on their write IOs. We're eliminating 32% of write IOs by displacing some of those, small, tiny, writes from Windows with more optimal IOs coming down. And since we're at that application layer, we know what the storage latency time is. If you had to serve many small IOs versus one larger contiguous IO, or versus if you had to serve that IO from storage instead of caching it from DRAM, which we're able to do. And since we're sitting at the application layer, we're aggregating your storage IO time savings. So you're not just seeing the percentage of the IO capacity that we're handing back to your storage system, you're just seeing the actual time that you're actually saving as a result of doing that. So the software is fully transparent on the level of benefits given to any system. And when you do install the software, you do have to give it 24 hours for its algorithms to adjust. But after it's running in production for a few days, that's when you can pull up the dashboard and take a look at what it's actually doing for you. Now, this slide is a very, very important slide. We mentioned you can get a 2x faster SQL experience with our software. Well, what are the steps that must be completed? The best practice steps to get a 2x or faster SQL experience. Well, step number one is, if you can, just add more DRAM to that system if at all possible. Now, I know the very next question will say, Brian, how much? Well, if you can afford it, add 16 gig to that VM, because with that 16 gig, you're going to get better than 2x performance with that 16 gig. But if you don't have 16 gig, if you can afford 8 or you can afford 4, add 8 or add 4, just add what you can afford. Now, the next thing, step 2, the next thing you need to do, and this is very important, is you need to cap SQL memory usage. Because now that you've added memory, SQL will just gobble it all up, and SQL is highly inefficient in its memory usage. It's one of the primary reasons why SQL is a sweet spot for us, because of how inefficient it is and how it uses memory. So that's why it's critically important that you cap SQL and you leave that additional memory for the OS and for our software, because we'll pick up whatever the OS isn't using. Now, if you're on the call here and you're saying, well, Brian, this is a physical server that I want to install it on, I can't just crack open the box and add more memory, that's fine. If that's the case, all you need to do is cap SQL a little more aggressively, leaving at least 8 gig for the OS and for our software to pick up whatever remains. You may not get to 2x gains, but you'll likely get to a 50% gain just by doing that. And you should know that our cache can leverage up to 128 gig. Those customers of ours with the hardest hitting systems, they'll use that full 128 and serve 90+% of their read IO straight out of DRAM on their read heavy applications, and get huge gains from that. Now, step 3, as I mentioned, you'll wait a few days, pull up the dashboard, and see what the software is doing for you. If you see that we're offloading less than 50% I/O from storage, well, the answer is pretty simple. Just add a little more memory, particularly if it's a read-heavy application. Add a little more memory and watch that number rise. And we've just done this enough times across tens of thousands of systems. We know that when you get to that 50% mark, that you're getting at least a 2x faster experience, at least from VM to storage, barring any network delivery issues to your users. So we're going to just close out here, just telling you what's going to happen next, and then let's move to a full Q&A session. But you're going to get your NFR. All you have to do is just take it, download it, install it. It should take you less than 5 minutes. Allow 24 hours for the algorithms to adjust, and then pull up the dashboard after a few days in production environment to see the benefits. Now you see the great big bold OR on the screen, and you can see that OR is, we have actually a recommended approach, because as much as you can install that one NFR on one VM, there's one problem, and that's the fact that if we're optimizing one SQL server on a virtual machine, there's all the other VMs sitting on the same host hypervisor that are sending down a minimum of 30 to 40% I/O. That's just pure noise, and that's stealing those IOPS and bandwidth and resources that you would want to go to your SQL server. So you can contact us. You will receive the software from a Condusiv account manager, And if you like, they'll connect you with an SC and help you evaluate a 30-day trial on all the VMs on the same host. It's the only way that you can actually see the full power of what the software can do. Clearly, you can start by installing the one NFR, but you will not see nearly you won't see near the results that you would see unless you're installing the software on all the VMs on the same host. It's one of the reasons why we have a pricing option by host, so that way you can install the software to any number of VMs and not pay a penalty on price for doing so. And if you have more VMs than it would take to install one at a time using the standalone, we can stand up a free centralized management console for you. It takes no more than 20 minutes to stand it up and push out to as many VMs as you like. So, GQ, with that said, I know we've gone over maybe by 5 minutes, but I just want to pause there. Did I miss anything? And should we go to full Q&A? GQ, are you with me?
I am, Brian. I'm sorry, I'm muted out here. I think you covered everything, Brian. Just want to point out one more thing that you already pointed out, and that is the importance of capping SQL memory. SQL is not very efficient on what it does with memory. It will just load all its databases into memory, even though a lot of those databases aren't getting access. So leaving a little bit of memory for us to use, you'll get those big performance gains. And our sales reps or SE can point you to a knowledge base article from Microsoft on how to limit that if you need help.
Yep. And clearly, we're here on standby to give you free consultation if you need any assistance at all. And where we would like to engage you is after you actually get the software in running, and after it's been running in your environment for a few days or 10 days in a production environment, reach out to us. Let us know you're ready to review your dashboard. We'll have an SC join the call with you, look at the dashboard with you, see what type of results you're getting, and see if there's any recommendations we can give you. And if you're only using the single standalone, NFR on one system, you might be interested in talking with us about evaluating on all the VMs on the same host, so that way you can see the true power of what the software can do. So, GQ, I haven't seen a lot of questions come in. I know if you're on the webinar right now, looks like everyone has hung with us up to this point. If you do have any questions, let's get those in, and then GQ and I will start addressing those, or I should say GQ will start addressing those. Now,
well,
GQ, I think that you see the one that came in from Joe.
I did not see that one.
Oh, well, then maybe it was addressed to me. He's asking, our two patented I/O optimization engines, is it specific to SQL or server-wide? And Joe, I think that maybe we should clarify. It's not specific to SQL. It's specific to Windows. Any hard-hitting I/O intensive application that's running on Windows should be using our software to address those underlying I/O degradation issues, and obviously at the same point set up that tier 0 cache. So it's not specific to SQL, but that being said, SQL has become the sweet spot for where end users use our software. We just deliver a lot of performance on SQL systems. It's not just because they are so I/O intensive and I/O heavy. It's also because SQL is highly inefficient in how it uses and leverages memory. That's why adding just a little more memory to those servers and giving that extra memory to us drives big gains. Now, another question has come in. Will this presentation be available for download so I can share with my team? Yeah, you're actually going to get a couple things from us. Right after this webinar is over, you will be getting a link to the deck that we used today that you can reference yourself or share with your team. And also, we will be giving you the full on-demand webinar, so you have that available. It takes a little time for that to render, so your Condusiv account manager will follow up, send an email probably tomorrow that actually has the full on-demand here. And if for any reason you would like this same presentation to be given to your management or the other stakeholders on your team, obviously we're more than willing to do that for you.
Great. And then I see Jeff says, can you verify that the hypervisor can be Hyper-V and VMware? What's nice about our product is that we're running on the VM. So we're agnostic to the hypervisor. It can be Hyper-V, it can be VMware, it can be Citrix. We're fine with that. So no problem with that. I also see John said, I'm interested in trying the NFR on a MS Exchange 2003 32-bit. Yes, it will work in that environment. We'll get you a version that will work on there, John. And
yeah, and John, you'll have to just let your Condusiv account manager know, and they'll help you with that. Now, Bruce asks here pricing options. And we do have two pricing options. You can buy the software per VM, per instance of the OS. That's the NFR that we're giving you. It's more than $500 MSRP value at the lowest volume tier. On the host side, it's over $3,000 per host. If you tack on a year of maintenance, that's another 25% by tacking on your maintenance, but that's also at the lowest volume tier. That price changes demonstrably with volume. So you can just ask your Condusiv account manager, and they can help you with that. We have found that the price point, should you stay per VM or per host, if your VM density is 7 or less and you don't see that changing, it makes sense to go with the per VM pricing model. But if your VM density is greater than 7, it just makes a lot more sense to go host, because even though the software is not installed on the host, we can price it by host and give you an all-you-can-eat buffet to push the software to as many VMs as you're running on that host or intend to run on that host someday.
Then I see someone asked a question about the safety of the data because they're worried about the caching and what happens if the system goes down. Data integrity was our first goal here, and our caching is only a read caching technology here. And what that means is that data that's in our cache is already on your storage. So if the system goes down, there is no loss of data. It's already, data is already on your storage. So no problem with data integrity. And then, Brian, I see someone else ask about, you're talking about virtual systems here. What about physical systems? And these same I/O bottlenecks that we talk about on virtual systems, they also occur on the physical systems too. And we'll give the same performance gains on your physical systems too.
Well, in fact, we find out that oftentimes on physical systems, there's generally over-provisioning from a memory resource standpoint that we can really leverage that memory and deliver some nice gains.
Yes.
You don't have the I/O blender effect per se, but you still have the same inefficiency from the Windows OS and the ability to set up a tier 0 cache. All right, GQ. I don't know that I'm seeing any other questions come in on my side.
I don't see any more here, but some good questions from the group.
Helen asked on the, can we get some contact information on the license info and also the product trial? Helen, you can bring that up directly with when you get an email from your Condusiv account manager, you can reply back to them and they can assist you in any way that's needed. And yeah, okay. Well, GQ, I don't see anything else that's coming in, at least right now, that we need to tackle. Those do seem to be the common questions that do come in. Any closing remarks on your side?
No, just from the tech side, Brian. I just enjoy people just putting the software on their system, set and forget it, and just wait a couple days, bring up the dashboard, and see the benefits. So I hope all of you will do that and get great benefits from this product.
Yep. Then I echo that from GQ. We just want to circle back with you after the software's been running, as I said, from a few days to 10 days. And once you're ready to review your dashboard, we just want to circle in with you and review that with you. If you run the single NFR on one system, if you've added memory and for whatever reason you're not seeing just gains that blow you away, the high likelihood is that it's simply just because the software is not running on all the other VMs. As I mentioned, are setting down a minimum of 30 to 40% I/O that's unnecessary. So to really see the full power of what we can do, that's where you want to get connected with us for a trial on all the VMs on your same host hypervisor and leverage our centralized management console if needed. So with that said, you'll be getting some follow-up emails from us, and we can't wait to hear about your results. So thank you, GQ. Appreciate your time today, and all those that hung in with us. We look forward to hearing from you.
Thanks, Brian. Thanks, everyone.
Thank you.